In this video, we'll be looking at the trig identities derivation, and I'll be demonstrating on that using this right angle triangle. This has been drawn not to scale, as we all know that the side that faces the angle in consideration is named as the opposite, while the longest side is named as the hypotenuse. Now, we're going to use SOHCAHTOA also and the Pythagorean theorem in order for us to be able to derive these identities, of which we know about the SOHCAHTOA. The SOHCAHTOA is written as this. In that way, we'll be considering the sine of the angle, the cosine of the angle, and the tangent of the angle. Now, if you look at the sine theta, if you're considering this angle called theta, if you look at the sine theta is going to be opposite over hypotenuse, and that one will be B over C. Again, if you look at the cos theta is going to be adjacent over hypotenuse, and that one is going to give us A over C. And we're going to look at the tan theta, which is going to give us the opposite over adjacent, and that will be B over A. If we have considered these three identities, I will also try to include another four set of these identities. Like, these are also the derivation, how you can derive the more advanced types of these identities. In that way, we're going to look at the cosec theta, and cosec theta is going to give us 1 over sine theta. And also, we're going to look at sec theta. Sec theta is going to be 1 over cos theta. Also, we're going to look at cot theta, which is going to be 1 over tan theta. Also, we should put this at the back of our mind that tan theta also can be written as sine theta over cos theta. If you have this is 1, 2, 3, 4, 5, 6, 7. If we have this written down and we have this one noted, we can go into this derivation. Without taking our time, I am going to use Pythagorean theorem in this. I'm using the Pythagorean theorem. And what does it state? It states that the sum of the square of the remaining sides of the remaining side is equal to the square of the hypotenuse. What are we talking about? Is that c squared, this hypotenuse, c squared is equal to the sum of the square of these two sides, equals to a squared plus b squared. A squared plus b squared. That is what the Pythagorean theorem says. Now, if we divide through by c squared, let's see what will happen if we divide through by c squared. If we do that, that means we're going to have c squared over c squared equals to a squared over c squared plus b squared over c squared. In that way, we can say c divided by c squared equals to a divided by c squared plus b divided by c squared. we can see that. So c divided by c square will give us 1. And a divided by c, we are now allowed to go into this SOHCAHTOA and see which one that fits. A over c is from the cos theta. A over c is from the cos theta, so we can now have that as cos square theta, plus b over c is the one that goes with the sine theta, so we have that plus sine square theta. That means that cos square theta plus sine square theta will equals to 1. This is the first identity. This is the first one, and this is, I'm going to say this is going to give us like equation 1. That is the first one. So again, if we divide through by b squared, what do we have? If we divide this Pythagoras theorem, if we divide it by b squared, this is what we're going to have. If we now say c over b squared, I don't want us to take our time by saying c squared over b squared, then going back and forth. That's why I'm saying c over b squared will now equals to a over b squared, a over b squared plus b over b squared, b over b squared. So in that way, we know that c over b, if you look at c over b here, c over b looks like it's coming from the sine theta. It's coming from the sine theta. That means that c over b is an inverse of b over c. And that means that will be, if you trace it down, that will be cosec theta, because that one is 1 over sine theta. If you look at sine theta here, so if I'm going to put something here, this will be b over, if I'm going to put, let me just squeeze something here. So this is going to be c over b. That's going to be c over b. And sec theta, which is a over c, is going to be c over a. And cot theta, which is b over a, will be a over b. I think we've done something fantastic in there. So in that way, c over b will be cosec square theta, will be cosec square theta, and a over b will be cot, because cot is 1 over tan theta. Cot square theta, that will be cot square theta plus 1. Cot square theta plus 1. Cot square theta plus 1. And this one also is one of the identities. So I'll call this one 2. So if we move further and say we should divide through by, we are done with c, we are done with b, by a squared. If we divide through by a squared, so what will be from the Pythagoras theorem? That means that, which I have c squared equals to a squared plus b squared. The first one I'm going to do is going to be c over a squared will equal to a over a squared plus b over a squared. In that way, if we look at it again, that c over a is going to be C over A is going to be sec square theta. And A over A will give us 1. A over A will give us 1 plus B over A. B over A is tan theta from here. B over A is tan theta. B over A is tan theta. So that means we're going to have sec square theta equals to 1 plus tan square theta. This is another one. So we have how many now? If we are to look at it, that means we should be talking about 1, 2, 3, 4, 5, 6, 7. And we already know, we've seen the derivative of cosec theta, sec theta, and cot theta, because those ones are like the inverse of sin theta, cos theta, tan theta, respectively. And those are 7, and we saw that we are able to derive the Pythagoras, using the Pythagoras to derive cos square theta plus sin square theta to give 1. Again, we derive cosec square theta equals to cot square theta plus 1, and also sec square theta equals to 1 plus tan square theta. That means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good, and that's great. Also, I would want us to quickly look into this, because we are getting into the end of the class, but I will want us to quickly look into this that says that if we have sin square theta, this is very, very important in this trig. If you have sin square theta plus cos square theta equals to 1 from the Pythagorean theorem, we can obtain sin theta, we can obtain cos theta, we can also obtain sin square theta, we can also obtain cos square theta. So if sin square theta now is equals to 1 minus cos square theta, and also cos square theta will give us 1 minus sin square theta. That's good. And again, I brought something up here about this 90 minus theta. There is something we call the complementary angles. The complementary angles are the angles that when you add them together, you're going to have 90 degrees. When you add those two angles together, you're going to have 90 degrees. They are called the complementary angles. If you look at theta here, 90 minus theta is the complementary angle, if the complement angle of theta. So the two of them are complementary angles, and we're going to look into that. And when we look into that, this is what we're going to have. If I say that I'm going to just put those here. Give me 1 second on doing that. Maybe I'm going to turn this. If I turn this way, can I make something from there? I think yes, I can make something from there if I do it this way. So I'm going to use this opportunity to talk about the complementary angles. Complementary angles. So the first one is if I have sin theta. Sin theta is also equals to cos into bracket 90 minus theta. sine theta is also equals to cos 90 minus theta. The same way, cos theta is the same thing as sine 90 minus theta because they are called complementary angles. Also, once I mention this, you should be able to know where I'm going to. If I say cot theta is going to give us what? This is going to give us, whenever you mention cot, you are dealing with tan. So the complement angle of cot theta is going to be tan 90 minus theta. The same way, if you say tan theta, this is going to give you the complement angle of cot 90 minus theta. I hope you are getting it fine. So if I also mention that cosec theta is going to be sec 90 minus theta. Also, if I say sec theta, that is going to be cosec 90 minus theta. You can see them all like that they are complementary angles. You can use any of them to interchange, or you can convert one to the other. When you see sine theta and you found that you're dealing with cos 90 minus theta, you can convert it, and it's easier for you to prove them. If you want to prove sine theta, for example, you want to prove sine theta, put 30 into the angle. That is what you can prove, because you want to make sure that whatever you are using, they are perfect fit on that. So if I put 30 equals, if I put theta is equal to 30 degrees. So sine 30 degrees, if I look at sine 30 degrees, what would that give me? It's going to be the same as cos 90 minus 30, which is the same thing as cos 60. And cos 60 is going to give, if you look at cos 60, it's going to give 1 over 2, 0.5. That means that sine 30 is going to give you 0.5, and cos 60 is going to give you 0.5. The same thing if you say cos 30 here. Cos 30 will be the same thing as sine 60. And if you look at cos 30 is going to give you 1 over 2. Sine 60 is going to give you, if you look at cos 30, if you put 30, then if you put theta as 30, so you have cos 30, which is going to give you root 3 over 2. If you put sine into 90 minus 30, that's sine 60, and that one also is going to give you root 3 over 2. So you can convert them into one another. So these are the identities that I really want to bring out today for you. And also, this is another identity that I really wanted us to take notes about. They are called the negative angles. Identity for the negative angles. These are very, very important for negative angles. This shows that if I have sine theta, if I have sine minus theta, this should be the same thing as minus sine theta. Only one is different, which is cos theta. Sine into minus theta is the same thing as minus sine theta. And if you have cos into minus theta is the same thing as cos theta. It doesn't change. It's just like a cos minus theta is equal to cos theta. Then tan minus theta is the same thing as minus tan theta. I'm pretty sure these are very good. Let me just find a way to put them. These are very good identities. Therefore, the negative identities, sine minus theta is the same thing as minus sine theta. Cos minus theta is the same thing as cos theta. Tan minus theta is the same thing as minus tan theta. Thank you very much for listening, and thanks for watching the video. I will try and bring some examples on this in order for us to understand them very well. Thank you. See you in the next video. Thanks for watching. If this video was very helpful to you, please don't forget to thumbs up, subscribe to this YouTube channel. If you want more of these videos, please turn on the notification bell so that you can be notified when I upload my new videos. Thank you.